Hi and welcome to this third episode of our MiniStealth tutorial where we're creating a small roguelike stealth game using SpriteKit, and today we'll also start including GameplayKit. And today's goal is to be able to show the gameplay world, so the place the player can play around in. So what we will do that by separating sort of the visual representation of the world from the internal or simulation aspect of the world. We call that latter part the model, and the visual representation the view. And this is something you might have heard from in typical patterns like model view controller or model view controller, and there's many more. Basically it's sort of a separations of concern between showing something and describing something, or separating the actual game logic, so the rules of the game, from the way you show them on screen. So perhaps at some point in time you might take the same model and simply create a new view on top of it. So we will start by creating the model to describe the game world today, and this is also the first time we'll be using some GameplayKit features, in particularly a part of the entity component framework that's in GameplayKit. And in a future episode we'll be using more of GameplayKit by leveraging the built-in pathfinding solutions. But we'll start nice and simple, and we'll focus on describing our model. And our model is made up of four data structures. On the top we have a world, and the world it can be divided into two parts. A sort of static part, that's the map, that's basically the area you play around in, and the map is built up of various cells in a grid, and those describe things like a wall or a floor or something else. And we also have a more dynamic part, and that we will call those MS entities, for MiniStealth entities, and these are things that can change during the duration of the game. So the position might change, or I don't know, the health might change, something like that. So they're dynamic and they change. And the MS entities, we won't be creating those from scratch. What we'll do is we'll inherit from a GameplayKit class called a GK entity, that in itself contains a set of GK components. We won't be touching on components just yet today, but just be aware that once we start adding more logic and behavior to entities, we will do so using components. So this also makes this an example of using an entity component framework. And we will find out that this setup is actually quite flexible going forward. So we have classes, the world, and the entities. The entities need to be classes because a subclass of GK entity. We have a structure, the map, which, because it's also static, it will be immutable, makes it very easy to use it. And we will have cells, those are enums, and those are created simply describing describing parts of the world. In the future we'll add more data models or more data objects as required, but this will get us started. So what do we need? We need an enum called a cell, and this describes one static part of the game world's map, so sort of the filling in of a grid. And for now we have the three cases, so they can be void, which means it's completely, it's sort of nothingness. It's not like it's empty that you can stand in it. It's sort of, it doesn't exist. We have walls, which will probably block our players and block the line of sight. And we will have floors, and those are the places you can walk around on. We will be able to get a name for the cell back, and we can then use that name also to find the correct sprite in our asset catalog. And they will have a raw type, and we'll go into that a bit more detail once we start coding, but we use this as a bridge to the map making solution we're going to use for now. We also have our map structure, and this basically describes a map or a grid of cells. So it holds all the cells. We use a dictionary to store them that have a coordinate as a key and then retrieves back a cell. This is not the fastest solution because it means the vector needs to be hashed to be able to find in the cell. On the other hand, it's fast enough for now and it's really easy to use. So this is we'll roll for using this for now on, and in many turn-based solutions this is probably good enough. We will have a very simple API. We can initialize a map from a string, and we will see what that looks like when we start looking into the code. And we will be able to have a method that gets the various specific cell back based on a coordinate. And for now, if a coordinate is passed in that's sort of outside of the map, we'll just return void. And we will have some variables to determine the player start positions, the target positions, and enemy spawn positions. These are not these are sort of the initial positions for the entities. So it doesn't describe where an entity is, it just describes where they should be started or where they should spawn, and from after that the entity component system will take over. Then we have our entities. We call them MSEntity for MiniStealth entity, and these are this is a subclass of GKEntity, and this is the first part of GameplayKit we're using. And we use this to describe dynamic parts of the game world, or sort of the dynamic objects, or the monsters, the players, items you might find, stuff like that. And these, what differentiates them from a regular GKEntity is that they have a position, and the position is a vector. So we can use the same coordinate space for these entities as the game world, and they have a name. And the name should be the same as the sprite to show. So that makes it very easy to map from the description of the entity to the to finding the correct visual representation. Today we only talk about entities. Next time we'll also add components when we start making having the entities move around. So that's pretty easy. And finally, we have a class called world, and this is sort of a container for the map and all the entities. And this is also the one that will trigger, or that will steer all the simulation aspects, of which there aren't any yet, but that's the intended use. So it has a map, and the map is immutable, so it's a constant. It has a set of entities, and these entities are dynamic, so that's why it's a variable. And it holds a reference to the player because it helps a lot if you simply can ask or inspect the world and just get the player back. For instance, if you want to move the player around or send a command or something like that. And for now, all we will implement is an init or an initializer that initializes the world based on the map string. The API will become larger in the future. That's the model. The view itself is also quite simple. What we will do is each update, and at the start of the game we will clear the screen and then redraw the world. And we will use the cells in the map and render them on the background layer of our S console, and we will render the entities on the foreground layer on the of the S console. And this makes sure that you can see the background, or sort of the floor an entity is standing on, through the entity sprite itself. So this way we can leverage the fact that we have both a background and a foreground layer. So you could sort of compare it to old school systems where you have a background layer that describes the world and sprites in the foreground. Because it's all pretty simple, we'll just add to the gamescene.swift file. If you have a more complex game, you might want to create a dedicated controller file that sort of steers how the view reacts to changes in the game world. But for now, that's not really required, and only add complexity where we don't need it. So what will we be doing? We will have the following implementation sequence. So first we need to extend vector with a zero initializer or convenience initializer. And we also need hashable protocol conformance, otherwise you can't use it as a key in the maps cells dictionary. Then we will create the first part of the model that's just the cells, the map and the world. We will then look at showing the world. We will then add to the model the entity, so we can also describe a player, target and enemies, and of course we want to show them as well. And finally we add a splotch of color just to give the visuals a bit more, add a bit more feeling to the visuals. So without further ado, it's time to fire up Xcode, which, if I was a professional, I should have done way in advance. So we'll open MiniStealth, our project. And we have our vector struct, and what we will add two parts. We'll add a static variable called 0, and we'll type of vector, and it will return a vector with x and y set to 0. So this way we can create a new vector using vector.0, and this is a nice shorthand for something you might use a lot, because it's pretty common to initialize something with a 0 value. So that's just a bit of convenience. It's not necessary per se, but it saves on some typing later on. And second, what we need is we will have an extension to the vector, and we will add protocol conformance to hashable. And fortunately that can synthesized automatically by the Swift compiler, because both x and y are integers, and integers by itself is already hashable, and this makes the entire structure also hashable. And that means that if we go and later on start using it in a map, we can start using it as a key for all the cells. So that's the first step. We extended our vector. We haven't added any real behavior yet, so that's something that comes now. We will create a world based on the cells, the maps and the world, and I will do so in a separate group. So I'll call this a group or model, just to give it to make it a bit easier to keep organized. And we will start with the map.swift file, and that's just an empty file. And this will be a struct, and the struct will have a set of cells, or a dictionary of cells, that take a vector and map towards a cell. We haven't defined the cell enum yet, but because it's quite small we can do so below here. And we will start with just 3 cases. So we'll have a case void, and we have a case wall, and we have a case floor, and we will also have a name, and we will, that's a computed property that will return based on its value a bit better formatted version of the internal value. We have a wall, a void, and a floor. So this is the cell, and what we will do is we'll do a bit of trickery. I said we would have also a raw value for the enum. The reason is this. We want to find a way of creating or describing maps. So I think from here there are more or less two ways of doing this. Either you go the authored approach, so you hard code various maps into the game, or you go the procedural generation way, and then you create an algorithm that create an unlimited number of maps, and each one will be different each time you play the game. We will go for the authored one just because we want to make sure that we have maps that are also solvable. And creating good procedural generation is extremely complicated. It's kind of easy to create an algorithm that creates a map, perhaps even a good-looking map, but having one that's that creates maps that are fun to play and are fair and winnable is way more difficult. So we will go the authored approach, and that means that we need some way of describing what the map should look like. And we could use something like a tile editor. But for now we will go the easy way, and that's just adding it hard-coded into the game. And we're going to use a little trick. We will create a static variable called map strings. And this will be an array of strings. And we will use raw strings. And that means that you can have a string that spans multiple lines, like this. And the string will be interpretable in such a way that it describes the world. So dots will be floors, or periods will be floors. Hashes will be walls. The player will start at the @sign, enemies, and target. And we can later on add, well, we can add more or less as much as we want, but this is a very simple way of describing what it should look like. Okay, so let's see. So we have our map string that, well, as you can see, describes a floor or a map of the world, and we need to some way translating this into actual cells, and that's where the raw type comes in. If we give this a raw type of character, we can say case void equals space. And that means that if there's somewhere a space here, it will be, we can later translate to it from it towards a void. If we want to say, translate hashes into walls, we should say that a wall has a raw value of a hash. And the same for the floor. We will say that the floor has a raw value of a period. This doesn't yet cover the entities, but at least contains the static parts of the room. So the next step is to be able to create a world from this set from such a string. So we'll create an initializer that takes a map string, and then based on that populates the cells. And to do so, what we will do is we'll step through this string line by line and then character by character to interpret it. So first we need to translate the map string into a set of lines, and we will do a map string, and then we will split it and we'll use the end of line character to split, and we will reverse it because our coordinate system goes from the bottom to the top, whereas the lines are read from the top to the bottom. So if we don't reverse, then the map will show upside down. Might not be a problem for you, but if it is, simply reversing the lines is probably the easiest solution. Then we'll say we'll start at coordinate x and coordinate y 0, and we'll go line for line, so we'll go for line in lines, and then we'll go for each character in the line, and we'll see what kind of character that is. So we'll store the coordinate in a vector x and y, and then we'll have a look. So if the character equals an @ sign, we will want to store the player start position. Let's quickly add the player start position. So we have a player start position, and we'll initialize it as vector.0, and this is where the convenience initializer in vector comes in. We'll do the same as the target position, so that's the place you want to go on the map without being caught. And we'll have a couple of enemy spawn positions. This will be an array of vectors, and this will start off as an empty array. So we know we have the player start location. What we will then do is we'll say the player start position is the coordinate, and we will take the cells for coord and store it as a floor. So I assume that where there's a player start position, there's a floor beneath. Else if the character equals a t, we'll say the target position is the coordinate, and again assume that below that is a floor. Else if the character equals an e, we will append the enemy the coordinate we're currently on as the spawn position, as an enemy spawn position, and again assume that the below the enemy is a floor. So now we have interpreted all the entities, the t, the e, and the @ sign. Then we can try and interpret all the other characters. So we'll say our cells for the coordinate equals a cell with the raw value of the character. So this is a way of translating from a raw character like a hash into a value the enum understands. This might fail if you pass in a character that it doesn't recognize. For simplicity's sake, then we will default to void. And once we've done this for this single character, we'll increment the x value until we're done with the entire line. Then we need to set the x value again to 0, because we need to go direct to the start of the line, but go to the next line. So we will increment the y value. This should make it possible to interpret this map. Then we also want an inline. Inlineable is always a bit tricky to write. We will get a cell at a coordinate and send back a cell, and we will default, if it's a coordinate we don't know, to a void value. And I think this is all we need in the map for now. So we have our cell and our map done. Then we need to create a world. And for now the world will just be, it will be a final class world, and this will just have a map, and it will have an initializer, and it will set map to map string. Let's see, so now we have our cell map and world. Let's try and showing it, and to do so we need to go to our game scene, and we have our console here. We'll also add a world, and we'll make it implicitly unwrapped optional because we can make sure that we set it here. So we'll say our world is equal to a new world, and as a map string we will use the map string and then the first one. I think it's a bit nicer to call these map strings as in plural, so it's a bit more obvious that we're taking one from an array. And we have all this stuff here about drawing strings and so on. What I'll do is I'll keep this console clear here. We'll create a new function called show world, and we'll get rid of this one, and let's implement the show world function. And this one should let's see, call just show world there. What we need to do is we first clear the console when we show the world, then we'll say for tile in world.map.tiles. Did we call it cells? Is possible? Sure. And if the cell value is not a void, then let's try and showing it. So we'll say console.put background, because remember we do this at the background. We'll have our cell.value, that's the cell, and the name, that's the name we use for as the glyph to show, and we show it at the cell.key, that's the vector, so that's the location. And we should make sure that you have the assets. We don't have one called floor yet. We have our enemy, our player, and a wall. So I will just duplicate the square and call this one floor. And I think that if we run this, we should see a map without any entities just yet. Just the walls and the floors. Okay, cool. I'm quickly going to get rid of that hello world there, so I don't mind it being on the screen, but I'll put it way higher so it doesn't interfere with our map. So this is our map. We can clearly see it as it's also defined here in this world. So that's cool. So we met this objective to show the map. Now let's add the player, target, and enemies in the MSEntity object. So first we need to add the MSEntity class. And this one requires GameplayKit because we need to be able to create an MSEntity as a subclass of GKEntity. And we add two stored properties. We call a position, and we'll initialize it to 0, and we'll have a name that's unchangeable, and we'll create a convenience initializer for the name and the start position. This will be a vector, and we'll default it to 0, so if you don't pass one, we assume you remain at 0. The self.name will be name, and self.position will be position. Then we need to call the super initializer in the super class, and we need to this one is called start position, and we need to implement this required initializer, which we don't use. So if somebody calls it per accident, we'll just let the application crash as loudly as possible. So this is enough for the entity, the MSEntity class for now on. What we now need to do is also add these into the world. So we'll go to the world, and together with the map we will have a set of entities, and this will just be an array of MSEntity, and we'll have a player. This is a special one that will hold a reference to the player, and we'll also initialize these ones. So we'll say our player equals an MSEntity, and we'll call it the player, and we'll start at the map.playerStartPosition and append it to the entities array. Then we'll have the target, and this is also an MSEntity, call it target, and it will be at the target position, and we'll add it to the entities array. And finally we will have for each enemy spawn position we will have an enemy. So this also be an MSEntity, we'll call it enemy, and we'll use the enemy spawn position and append it to the entities. So this should let us also interpret the entities that were defined in the map itself here. But we also need to make sure that we can show them. So we need to go to our game scene and our show world method, and we will add the logic to show also entities. And to do so, we will loop through each entity in the world.entities, and for each entity we will put on the foreground the entity.name, and we'll take the entity's position to place it. And I think this should be enough to show also the players and the entities. Let's see, it looks like I can't find the target, and that's probably due to what do we call our target in the assets? Oh, we called it a treasure, so we're hunting for a treasure. That's not really a problem. We'll say our target is a treasure, so we rename this one in the world initializer, and it will now probably be able to map correctly. So we have a treasure, we have our enemies and a player, and if you look really close, you should be able to see the floor also below it and below the actual glyph. So we're almost there. The final thing I want to do is just add a little bit of color, because it all looks a bit boring, but we'll just add a very little bit of color, and we'll do that in our game scene, and we have a put background here, and we can add a color. And let's see, you can choose of course any color you want, but I have some values that I like for this instance. So I'll give it a hue, a saturation, a brightness, and an alpha. And I'll do the same for the entities. So I'll also add a color here, and I'll is the same calibrated hue, saturation brightness, alpha initializer with slightly different values, or at least a different hue, and I think this should be written as the zero with the leading 0. So the map now is a sort of bluish hue, and all the entities are yellow. This will become a bit more interesting when we start talking about lighting and for field of view and so on, but this should be good enough for now. So I think this meets all our requirements for this session, and I'll see you next time when we start moving the player around. So for now we only have a map viewer without any interactivity yet. Next time we'll start looking at interactivity by starting with allowing the player to walk around. Thanks for watching and have a very good day.